There are some pieces of technology that are so fundamental, so absolutely everywhere, that we don't even see them anymore. But without them, our world would literally, and I mean literally, grind to a halt. Today, we're going inside one of those.
So let me just start with a quick question. What do you think is the one thing that connects, say, the giant spinning blades of a wind turbine and the wheels of a high-speed train that's just blasting through the countryside?
Well, believe it or not, it's this the roller bearing. Yeah, I know, it doesn't look like much, right? But this little piece of precision engineering, it's the secret sauce behind almost every single thing that moves in the modern world.
And that's exactly what we're going to get into. How this tiny, unsung hero manages to carry the unbelievable weight of our biggest machines, and how it's getting shockingly smart. I mean, just think about it. They are tucked away inside the axles of those super fast trains. They're right at the heart of those massive wind turbines. They're buried deep inside aircraft engines. They're in your car's driveline and in the giant machines that build our cities. They're basically the critical link between the part that's standing still and the part that's spinning like crazy. And their one job is to make that happen as smoothly as humanly possible. But to pull that off, these little bearings have to deal with some just immense physical challenges. And the first, most obvious one, just sheer brute strength. Seriously, just pause for a second and think about this. How can something you can hold in your hand possibly survive the force of a 70-ton airplane slamming onto a runway, or the relentless crushing pressure inside a steel mill? The answer, of course, is just some absolutely brilliant engineering. So, way before anyone even thinks about forging metal, engineers build a perfect digital copy of the bearing. Then they use these incredibly powerful simulations to just torture that virtual bearing, hitting it with the most extreme forces they can dream up. They analyze every square micron of contact stress, and then they tweak the roller shape, often into this complex logarithmic profile, to spread that load out perfectly. The whole goal is to engineer it for the longest possible fatigue life. And this really shows you just how far we've come. We went from simple, solid steel rollers to these super lightweight, hollow, or even composite ones. Basic shapes got replaced by those perfectly optimized profiles we were just talking about. And we've swapped out standard steel for these incredibly pure advanced alloys, like ASI 52100, which is this amazing high-carbon chromium steel that's known for being ridiculously hard and tough. All of this is designed to handle stresses that we once thought were impossible. Okay, so being incredibly strong is one thing. That's half the battle, but there's this whole other war being fought at a microscopic level, and that's the battle against friction. And to win this battle, engineers use a principle with a really long name, elastohydrodynamic lubrication. But the idea is actually pretty simple. Under all that insane pressure, a super thin film of oil gets trapped between the metal surfaces. This little film gets so compressed, it acts like a solid for a split second, and it physically keeps the metal parts from ever touching. It's kind of like when your car's tires aquaplane on a wet road, but, happening on purpose on a microscopic scale. And engineers today are pushing this to the absolute edge. We're talking about designer lubricants cooked up in a lab, microtextures etched right onto the steel to hold that oil better, and these advanced, slick coatings, often based on things like molybdenum. It really is an all-out war on friction. And why does all this microscopic science matter? Well, it's simple. Less friction means less wasted energy. It means a wind turbine can squeeze more power out of a breeze. It means an electric car can go further on a single charge. You can draw a straight line from this tiny bit of physics to huge gains in global energy efficiency. But the story doesn't stop with just being strong and smooth. No way. The next huge leap is to give the bearing a brain, to turn it from just a passive, dumb component into an active, intelligent sensor. For, decades, the way we handled maintenance was, pretty basic. You'd just wait for a bearing to start making a funny noise, get worn out, and then fail. And that often meant a catastrophic shutdown for a factory, or a train, or even a whole power plant. It was expensive, and frankly, it was dangerous. The new way? It's a total game changer. Instead of waiting for something to break, the system can sense the very first signs of trouble. Instead of just fixing the broken part, it analyzes the data to figure out why it happened. And so, instead of just repeating that same old cycle, it allows engineers to predict the failure and prevent it before it ever happened. And they do this by packing the bearing with a whole suite of cool tech. You've got tiny sensors listening for changes in vibration, acoustics, and temperature, all in real time. All that data gets pumped into smart AI models, like graph neural networks, which are amazing at seeing the complex connections in the data. And these models work right alongside a digital twin, a live computer simulation of the real bearing to predict its health with unbelievable accuracy. So, after all that, where does this wild journey go next? Right? What does the future look like for our little unsung hero? Well, the whole mission has changed. The goal now isn't just about reducing friction or making things run a bit smoother. The new goal is to make failure itself a thing of the past. And the stuff researchers are working on is straight out of science fiction. I mean, imagine coatings that can lubricate themselves, or bearings with AI so advanced they can diagnose their own problems and send you an alert weeks ahead of time. We're also talking new materials for the insane heat of hypersonic flight, and even new ways to repair and reuse these parts, building a much more sustainable system. You know, the roller bearing is one of those technologies that's most successful when it's completely invisible. But maybe from now on, whether you're hopping in a car or on a train or on a plane, you'll give a little thought to that tiny, brilliant, hidden hero that's spinning away, carrying you smoothly on to wherever you're going. Thanks for joining me.